Okay, so let's start right now. So good morning to everybody. Welcome back for this new webinar session organized by Marpos. Today we are introducing you to our laser gauging solutions, and we have our two presenters, so Stefano Pasquone and Andrea Novelli. They are in Italy. They are making a huge effort to stay in an office until late. Why? Because they are so excited to show us the high level of performance of their solution that IRL offers for Marpos and for you customers and distributors. So just a few notes about the rule of the webinar. So please, if you have any question, use the question and answer section. Don't use the chat. We will try to capture also your question in the chat, but please use the question and answer session. There will be like a presentation with a live demo, followed by like the questions that you have made and the answers of Stefano and Andrea. So I will make Stefano and Andrea like a host of the right now of the webinar, so they will be running the webinar. So thank you all.
Thank you, Matteo. Welcome to all the people connected to this webinar. I am Stefano Pasquone.
I am Andrea Novelli.
We work here in IRL Marpos Group Italy, and I will start directly with the first part of this webinar, that is a PowerPoint presentation about the technology and the IRL products. And the second part of this webinar will be a live demo about the 3 benchtop system for the measurement of the diameter in the mechanical industry that are the focus product for the sales network in USA. And at the end will be a little question time. I start directly with the PowerPoint presentation. This is the Marpos Group headquarters in Bentivoglio, near Bologna, Italy. And like I think you know, Marpos Group is a worldwide group present in 34 countries with more than 3,700 employees. In Marpos Group and also in a part of other company that has acquired during the year by Marpos, like our company, that is IRL company, founded in 1978 and joined by Marpos in 2017. Since 1980, the business of IRL is to make laser micrometers and systems for diameter measurement. So IRL company is focused since 40 years in this only type of products. The laser technology allows a very high accuracy, the measurement of the diameter without contact, measurement online of the product. In some cases can give the feedback to the machine in the control of the process, make offline quality check, like the system we will show today, and also to give process and product certification. A little info about the function, how does it work, this technology. Normally, the various models of laser sensor are made by an emitter of a laser beam and a receiver. These make a measurement field and when some object is put in the measurement field, it creates a shadow. The technology is to measure the time of this shadow. Measuring the time of this shadow, knowing the speed of the laser beam in the measurement field and the total distance, we can calculate with very high accuracy the dimension, the diameter of the product that are put in the laser field. There is a simple concept, but with an high-tech optic and electronic design that IRL developed in 40 years of focusing in this type of product. The system is, the laser sensor are made with this type of diagram, or this design, scheme, with a laser source, an optics that make the focalization of this laser light. Can be one or more mirror that give to the laser trail all the length that you need. The heart of the system is a rotating mirror with 12 faces that rotate. When the laser beam touch the faces of this rotating mirror was deviated with a very high speed to obtain a scan frequency of 1,500 scans per second. So this system makes the measurement of the diameter of the product that are in the laser field 1,500 times per second. There is a transmitting lens that have the goal to make the laser beam very straight, very horizontal during all is scanning the laser, the measurement field, and the receiving lens. The receiving lens have to focus the laser light in a photodiode that simply give the signal, the trigger, if there is light or shadow. From this trigger, we can make the measurement of the time of light and shadow, and so understand and calculate with an electronic the diameter of the product. There is a simple idea developed in 40 years, but with an high quantity of technology. These technology are in the various model of laser dual axis or single axis, starting from the smallest to the bigger. So we can measure the diameter of product starting from 20 microns with the various models until 210 millimeters. But so this laser sensor can be applied in a various in a big range of industrial sector in real working for measurement inline and offline. Now I play a little video that we call it concerto that show some of the application of the laser sensor type of industries: pipe, extruded pipe industry, wire industry, the measurement of bar after a grinding process, integration in automation, measurement of shaft, also measurement of cigarettes, because the non-contact technology can allow the measurement of soft product without problem. The measurement of big bar with also the feedback to the machine. The system can work in very harsh environments with various type of protection of the optics, and can measure also transparent products, or in some cases also non-round products. There are benchtop applications, but a lot of application online. This is another portable product that is not focused in this webinar. And so you can see that the applications are a big number of applications in real work condition, and that can allow the control of the production, in some cases the 100% of the production, and in some other also to give the feedback to the machine, to control in real time the production of the change of the production. We can go on, but the bigger strategy is not only to give to the customer simple measurement sensor, like our competitor make. But we, in this 40 years of experience, we try to select some strategic application area with some measurement problem that come from the customer, and design some complete solution with dedicated system that are made not only by the laser sensor, but also a specific application software, because its diameter from 20 micron, from 20 micron to bar of 200 millimeters. The measurement is the same, is the diameter, but the needed in the control of the process or in the need of the customer are different. So there are specific application software in the memory, stored in the memory of the laser sensor, the laser gauge, software option like feedback to the machine or statistic reports, mechanical accessories like piece support of the piece, or
mechanical
transportation, cleaning of the piece, electronic accessory like, I don't know, Profibus or Profinet converter, display panels, and so on. So the solution is not a simple measurement solution, but a complete solution for the customer. Today, we will show the benchtop measurement system, think mainly for the mechanical industry, and that are based on two models of our laser gauges, the model XLS40 and XLS80. Normally, the number that is linked to the name of the product is linked with the measurement field of the sensor. So the XLS40 have a measuring field of 40 meters is too much, 40 millimeters, and the XLS80 a measurement field of 80 millimeters. So when you will see in the various brochure a commercial name of the various product, there is every time a number that is the measurement field of the laser sensor. The measurable diameters, normally the maximum measurable diameter is some millimeter less than the measurement field. So for the XLS40, the measurable diameters in the full range are from 0.1 to 38 millimeter. And for the XLS80 from 0.75 to 78 millimeters. These are absolute measurement systems, so they are mastered, calibrated for the full range of the measurement field without any need of recalibration when you change the diameter that you have to measure. The repeatability is very wonderful. The XLS40 with measurement with a measurement time of 1 second is better than 0.07 micron, so less than 1/10 of a micron. And for XLS80, the repeatability is 0.2 microns. The linearity with the product in the center of the measurement field, that is have in this value also the error of the master that we use for the calibration of our instrument, that is 0.3 micron, the master that the certified laboratory give us to make the calibration of our system, is plus or minus 0.5 micron for the XLX40 and plus or minus 1 micron for the XLX80. Starting from this TIS2 laser sensor, today we will show the 3 model of the benchtop laser system for the diameter measurement, from the simple, the double gauge, and the model in the middle, medium, the MacLab X, and the high-end, that is the Super MacLab Plus X. Now, some note about this system. The double gauge can be the double gauge X40 or the double gauge X80 that are equipped with the XLX40 and XLX80 millimeters. So for measurement up to 38 millimeter and for measurement up to 78 millimeters. There is the entry level, the simple off-fly system for the diameter measurement and the tolerance check, equipped with a low-cost LED display with 6 digits and multicolor, can change if you program the nominal value of the diameter and the tolerance that you want to check, change the color if the product is in or out the range of tolerance. Can be programmed with a remote control or with a PC connected to the Ethernet sockets. And in the rear of the display, you can have 4 alarm output and 2 inputs. Alarm out can be for a traffic light to see the tolerance status of the product, and the input can be, for example, a foot switch to give the start and stop of measurement without using the hand. Normally, it's equipped with a simple block to hold the part, and can use also a simple PC software to transfer the data to an Excel spreadsheet. The middle system is the MacLab family. It's possible the MacLab X40, equipped with the XLX40 laser gauge, and MacLab X80 with the XLX80. The main difference is the display panel. In this case, is not a simple display, but a control panel with a sensitive keyboard that you can use to program the system and to see up to 3 values that you can measure. This system, like the double gauge, has an industrial design, so you can use it in the floor shop, in the workshop near the machine. It can be equipped with a V-block for the hold of the part, and also this system can be connected to a PC to export the data, transfer the data to an Excel spreadsheet. With this software, with the macro, you can make your own mask for the measurement report and so on. The high-end system is the Super MacLab Plus X40. Also this with the 2 laser sensor models, the XLX40 and XLS80. It's equipped with a linear slide, a high precision linear slide, and he have a PC card mounted in the base, and a monitor for a user-friendly. You can use like a PC using a mouse and a keyboard, on only the mouse, like you use a normal PC. a keyboard, a PC are supplied with the system. It's a simple data display. The linear slide can be equipped with a magnetic scale to see also where you make the measurement in the part. Can check up to 10 sections, 10 diameter in the same piece, like shafts or other objects, and can make field measurement. We will see in the live demo. There is, like also other system, a parts library, statistic report, and so on, that you can export to the USB or with the network. The slide can be provided with a wide range of fixtures and accessories, digital scale, fine movement with a micrometric screw, and so on. So we develop a lot of type of holder of support for the piece to fulfill in the best way all the needed of the customer. Now we pass to the live demo directly on the system. So I switch the camera to the other the image to the other camera. And we start with the first two systems we have in the first is the table gauge. Like I said to you, is the simplest system with the laser sensor, a basement, a V block to where you put the piece, and simply you put the piece in the V block and you have the measurement on the display. I previously programmed the nominal and the tolerance of this piece, so you can see that when the product is in tolerance, the display became green. For example, if I change the product, I put another object that is out of the range of tolerance that is programmed, you see that the display became red. The system can be simply programmed and with a remote control, in which you can program the nominal or the upper tolerance, the reference diameter, the upper tolerance, the lower tolerance, and so on. And you can recall the recipe of the product that you can store in the memory of the sensor, and so on. Here there are some output for the light or input for external switch to give the start and stop of the measurement, and can be simply connected, wait a moment, with a PC. Directly using the Ethernet socket that is in the rear of the display, and you can connect simply to using simply a IP address that is derived from the serial number of the laser sensor. You can simply use a web browser to see the web server that is in the memory of the system. So you can see the measurement, program all the various parameters of the product on the system, and also to see for example, the video signal of the laser light. So you can see, you can also check the cleaning of the lenses. Like you see, this is the video signal. If put out the product, the video signal is a full light. If I put the products, there is the shadow, that is the distance that is used by the electronic to measure the diameter of the product. I can also make to see you the Excel software that is simply used. I check its position. It can simply uses to take the data. So like in this case, I can put the system. You see that in this case is the refresh every 1 second. It put the measurement that I collect during the measurement. If you can simply collect this data and make directly your statistic using the Excel spreadsheet. Now we can pass to the MATLAB system. In this case, is equipped with the XLS80 laser sensor that can make measurement from more or less 1 millimeter to 78 millimeters. Also, in this case, simply putting the piece in the laser field, we see the measurement is red because it's out of tolerance. The system is fully calibrated in the full range, so simply changing the piece, you can measure in all the measurement field of the product without any problem. The interface in this case is the CL200 panel that in this case is mounted in a benchtop base, but is the same that is other type of system is mounted in the rack and have all the input and output also to connect to the machine in other type of application. It can be simply programmed with a series of menu and so on. And it can use it without problem to see more than one value or measurement value in near the machine without any type of problem. Now, a little, I come back to the camera because my colleague have to change the position of the other camera to go in the other side of our web conference room to take a look of our high-end benchtop system for the diameter measurement, thinked normally for the mechanical industry. That is the Super MATLAB system. Now I change, okay, we are right. Like you can see, there is the most complete system that we can propose. Is the same, the heart of the system are all the same. The laser sensor, so the accuracy, the repeatability is the same in every model. Change the configuration of the system. In this case, there is a basement, a granite basement, in which is mounted the laser sensor and the precision linear slide that have also a digital scale to see the position, like you can see, changing the position, change the value of the position, and that can be simply zeroed with some automatic procedure, for example, on the beginning of the piece without problem. In the basic, there is a PC card that give like a normal PC to the monitor. In this case, there are some menus, so like the setup, you can set up a lot of parameters and so on. We can see directly the measurement, in which you will have a screen, a windows to program the various type of measurements. You can program also the nominal value and the tolerance and so on. In this case, I prepare a measurement reside to make the measurement on fly of this hydraulic spool. You know that this type of object required a very tight tolerance in the order of some micron. And we have a lot of customers all over the world that use our system to make the offline check of this hydraulic spool. In this case, I put the spool in one of our support, that is this couple of dead centers. And so I programmed 4 sections in the spool. In this way, simply passing through the object in the measurement field, I have the measurement of the 4 sections. They are all green, and the traffic light is green, so the piece is okay. Like you can see, I simply can change the piece. I put the same in this case. I start the measurement. I pass the piece, and I have the 4 measurements in the screen. If I am too fast, the system says to me that I collected a few scans. I collected a few scans in the various sections, so I have to come back because I program normally in the measurement position, the measurement of the slice in which I want to take the measurement. In this case, the slice is of 1 millimeter, and the number of scans that I want to collect to make the average value. So, like you can see, I can collect 4 sections in the same time. Wait a moment that I forget the section. Okay. In this case, you can have a report of all the measurements you take. You can have some type of report that you can print or save in Excel or TXT format. I can also some type of graph about the measurement, or with histograms that show me the normal distribution and the tolerance limits, or the trend of measurement, and so on. All our system can be calibrated by the customer with this calibration. If the customer wants to calibrate with this master, the calibration can be made also for the other system with a single master or with a set of masters. And the measurement we can make also with this system other type of measurement, not only of the diameter but also of tools, but is not the matter of the webinar of today. I don't know if what we can do, Matteo, if we
Stefano.
Matteo, if we have.
Yeah, can you hear? We have some question. There is a lot of interest, and thank you so much. Your presentation is great. Also, the live demo. How often? And we'll start with some questions because also those are useful for any of the attendees of the webinar. So, how often does the system need to be calibrated?
There are systems that are calibrated only in the factory because we make in our calibration with a set of master that start from from the minimum the measurement diameter to the big measurement diameter, so the system is perfectly linearized for all the measurements. So, like you can see, I can put a 4 millimeter object, or wait a moment, I have also to put down the V block, and it not need any type of calibration. Sure, like the quality book of a company, like every type of system, can need periodically a calibration check that can be made by the customer with his certified master, and so periodically, but depending on the quality book of the company, make this type of control like he made for every type of measurement instrument. So this check can be made directly by the customer, and the calibration can be needed if the customer wants to, because is sure that the metrology chain, Italian metrology chain, can be a little different from the American metrology chain. So also our master of calibration have an error, normally plus or minus 0.3 microns. So is an error that we add to the linearity of our product. And so if the customer have various plant with all this or various system and wants to calibrate with this set of master, he can calibrate by himself, surely with the careful that this type of operation need.
Okay, just a note for all attendees, the measurements that we have seen so far are all in millimeters, so you can appreciate that we are talking decimal of micron.
Yeah.
There is one specific question about what does linearity mean? 0.07 micron repeatability plus minus 0.5 micron linearity.
Yes. Okay. Surely the measurement can be in this demonstration. We put the measurement in the international system, so millimeters, centigrade degrees, and so on. But can be changed in the imperial measurement units. About repeatability and linearity, the repeatability is the error that the system makes measuring the same object in the same position. Like you can see in this case, you see that the last figure is the 10th of microns, and like you can see, the measurement is stable and only with a 1 second measurement time. So I forget to say is that the system make 1,500 measurements per second. No, maybe I said this. And so there is an average of 1,500 scan. So the repeatability is a characteristic of the sensor. It give, if you put the same object in the same position, give the same measurement with this value. And our value are for big masters. So for the XLS40 are declared for a master of 30 millimeter. Surely with small diameter, the repeatability is better than this, that is outstanding. We give in our datasheet 3 types of linearity error. The linearity error is the difference from the value that you read with the real value of the diameter, because all the type of masters have a nominal value, but also an error. So if I check the certificate that the metrology laboratory give me for a master, give me a value, but also an error. So the linearity is the difference that we can have for the system that is calibrated in Italy in our laboratory to the value of the diameter of the products all over the world. Surely, if the customer wants to cut also this value of linearity, we declare three values of linearity. The linearity for centered product, so there is the linearity in the middle of the product, the linearity in the full range, so moving vertically the object, and the horizontal linearity, if the object is moved between the emitter and the receiver. These two types of linearity is normally due for the online application, in which may be that the product is not perfectly centered in the measurement field. So if the customer wants to cut this type of value and have only the value of his master, he can make a remastering. In any case, the difference may be some tenth of a micron, 1/10 of a micron. So I think that the accuracy or the uncertainty, like we prefer to speak, is uncertainty is very low, the accuracy is very high. I hope that I have answered to the question.
We know that there are other additional questions that we are going to review maybe later on. I try to merge two questions in just one. How is the gauge and the measurement affected by coolant and temperature?
Okay, this is a type of optic measurement. So if there is some dirty in the surface of the product, I make the measurement of the object, but also of the dirty. So normally, in the benchtop application, the product will be simply cleaned before the measurement, and this type of problem of dirty may be in some type of inline application, like after a grinder machine, where we check 100% of the product that come out from a centerless grinder machine. So, because to go in the transportation belts that put the piece in the measurement field, we studied in these years some type of cleaning station that can put out the coolant if it's an emulsion of water and a few percentage of oil, like 2 or 3% of oil. And the temperature is another matter. I don't speak about this because we need another webinar about the NOVAR technology that we have in our laser sensor. The NOVAR technology is something, a technology that can allow to use this type of system in a not controlled temperature environment, like you will be in a metrology room. Why? In few words, the temperature can affect the piece, and if you know the material and so the thermal expansion coefficient of the product, is easy to know how it changes the size, changing the temperature, because in a simple physics law. More difficult is to know how work the measurement system, because also the measurement system change the measurement, changing the condition of temperature when it is out from the reference of 20 degrees. We develop a technology for which, for each single sensor, not for a typical value, but each sensor, we make a procedure so we can know how change the behavior of the measurement of the sensor, changing the temperature. These data are collected, are stored in the memory of the laser sensor. in the laser sensor, there are two temperature sensors, and so I can estimate the ambient temperature, and this value allows our system to understand which is the temperature of the environment, how work the piece, and how work the laser sensor. In this way, we have all the incognito of the question, and we can understand how it works. We can also, if we know the temperature of the product, we can, and so the important in this case is that the piece and the laser sensor are in equilibrium with the environment, with the changing that is not big, in inner 3 degrees per hour. In any case, we can also change the type of compensation with an offset if we know that the products are every time some degree hottest or coldest of the environment. So programming an offset of temperature or a fixed temperature if we know exactly the temperature of the pieces that are kept, for example, by a thermal bay. So is our way in which we can be sure that we can have measurement near the machine with this type of sensor, or after in line, like we take a sample and we put in the metrology room. These three types of systems that you see are applied from a lot of our customers in the workshop, in the measurement island near the machine. The operator take the pieces from the machine and put in the measurement system. There are no problem of the skillness of the operator, because the measurement is independent from the operator, is independent if you use a hand micrometer or caliper, that the measurement can change between one man and another, is an absolute measurement without any problem of the skillness of the people.
Okay, so let's move to some questions also that are interesting for all of us about the competition. Most of you are aware that Keyence can be a competitor, and we have two specific questions for that. One that is during the presentation, you were saying that the IRL laser sensor has a measurement frequencies of 1.500 Hertz, but some Keyence models has 16,000 Hertz. So which are the differences? And the second question is always related to Keyence is what are the differences with the green LED of Keyence?
Yes, some systems. The first difference between Keyence and IRL is that Keyence don't supply only the simple sensor, can supply only the simple sensor used by a machine builder or OEM or integrators to put in his machine, like Keyence, but give only a dedicated and complete system with a lot of accessories, specific software, not a multi-purpose software like Keyence. We dedicate the measurement directly to the problem of the customer. About the technology is a little difference. We use, like I show you, the laser source and the rotating mirror, and Keyence use a LED light and a CCD matrix, a CCD sensor. This allows to Keyence to have a measurement frequency that is more than 10 times our measurement frequency. But at the end is like the difference in a battle from a machine gun and a sniper. Keyence is like a machine gun. So to take the enemy have to shot a very high number of shot of bullets. We are snipers, so because the precision of the single bullet of the ROL scan is better than the single bullet of the machine gun of Kiens, we need less shot to have the same results, to kill the enemy. And so at the end, also if the scan frequency of Kiens is 10 times the scan frequency of IRL laser, at the end, if we take the same measurement time, so we make an average for, I don't know, 1/10 of second or 1 second, the repeatability of IRL system is higher. Or, at contrary, we can keep the same repeatability of Kiens sensor with less time. Because, like you understand, when I have the value of measurement that are used, I don't take the single bullet, so the single shot, but I make an average, maybe a short average of, I don't know, 24 or 100 scan, or more big average, like 1 second, like I show you in the steady measurement, in which we have the repeatability of 0.07 micron. Starting from the technology, also we have a red light that you can see with the video, maybe not so. So there is a blade of red light, and we use the rotating mirror. Kiens says, but we are better because we use only solid states technology without any movement part and so on, because they don't use the rotating mirror that have a motor. The problem is that we don't have any type of problem with this type of motor. It's a motor with a technology of the hard disk, so I think that every one of us have a hard disk that was breaked, but for sure the break was in some components of the electronics, and the motor continues to run without problem. So in the last model of motor that we use is starting from 10 years, I think, or more than 10 years. We mount, I think, more than 6,000 of motor. And in this 6,000 of motor, we substitute only 2, maybe. For a shock, not for problem, because there was application in line, and so the laser sensor was bumped by something. So I remember that in IRL laser sensor, there are 3 years of guarantee. I think that Kiens don't give 3 years of guarantee in his laser sensor.
We have a question, maybe that is related. What is the MTBF of your motor, and why don't you use a galvanometer?
Quante ore di vita è garantito il motore? I don't remember. Sincerely,
But it's something that we have in our catalog, right? That is a number that we can share, right?
Yes, yes, for sure. In any case, like I said to you, in our motor, in 10 years, and we have a system that works 20 years without any problem. The motor is the part that never breaks. Also, the other part that can be due to consumption, maybe the laser source. In any case, they are, I think, 100,000 hours of guarantee working time, and this more. So normally the problem can be some type of electronic components that burn, but normally in the two part that is the motor and the laser light, there are no any type of problem. In any case, in the catalog, I think that you can reach this type of statistic.
Another interesting question, and I'm sorry, Stefano, if it's like continuous, but can the roughness of the part affect accuracy or uncertainty of measurements?
Okay, the roughness of the part don't affect repetibility and accuracy. Change the measurement that I take with the optic measurement and compared with a measurement that I can take with a touch measurement, because for sure, if I have a turned part with maybe a very big turning step, when I make the measurement with a mechanical micrometers, I put the two, I don't know the English word for the piattelli. I don't know if Matteo, you can help me. The touching part of the touch probe, I don't know, the head of the touch probe, surely touch the product in the top part of the screw helix of the turning step. And if you make the measurement with the laser sensor, depending, now I introduce another type of arguments that I don't show in my presentation. In any case, the shadow made by the turning pass, the turning step, cutted by the laser light is not surely maybe in the top position, in the top and in the higher position, in the top and in the bottom of the piece. So surely the optic measurement is a little lower. This is not fixed, because depend from two factors. The type of roughness or the type of turning step of the product, and the width of the laser beam. We can offer two standard width of laser beam. One that is, and in the various model they are indicated, but the last, when we have the name, the commercial name of the sensor, that is maybe XLX 80, XLX 40 slash 1500, that is the frequency, slash a letter that can be A or B. And this change the width of the laser beam. The A laser beam is bigger. For example, the laser beam A for the XLX40 is 2 millimeters. The slash B laser beam is tight, and this example, and is 0.1 millimeter. Why we made these two type of laser beam? Because can be different need from the customer. For example, when we have to measure in the benchtop application, and I need to go in small groove, I need a very small laser beam. So, like in this case, if I have to go in the, as there is a pro, it's difficult. Okay. So the slash B that is tight need to see all the profile, all the small, I don't know, definition of the product. In contrary, drawback is that may be more affected by the dust. So if there is a small grain of dust or a small drop of emulsion, I see the measurement of the piece and also of the dust. The larger make an average in a bigger slice of the piece. So if the slash B is 0.1 millimeter, the slash A is 2 millimeter. So it can less affected by the roughness of the part or of the turning step of the part, or if there is a very small grain dust on the part. So normally is used in online application like measurement of bars or grinded parts or in the extrusion and so on. So surely in another part, if we know that our type of roughness and or turning of the surface give every time, I don't know, 2 micron of difference between the reference that I take with the manual caliper with my reference system, I can also program an offset to change in a small way this type of changing. We make, for the measurement, I don't have here, for the measurement of part with a big problem in the turning step, in the turning surface, a support for the Super MATLAB that can be used with the XLX80 that allow to horizontally rotate the laser sensor. In this way, like you can imagine, if I take the laser light in this way, I have no problem of measurement because I take, in any case, the real diameter of the product, but taking the slice in this way, I take for sure the top and the maximum top and the minimum bottom of the diameter. So in this way, I can have the same measurement that I have with other type of touch probe or touch measurement system. I don't show you other type of support like motorized centers, like fixed block, like block with roller, and so on. In this year, we develop all this type that can simply put in the linear slide with a screwdriver and change it in position.
Okay, so we are basically over the hour of our webinar. I know that we have other questions, but please, you can reach out to us for any question. I don't know, Stefano, if you go back to the presentation and share the last slide. To all of you, we would like to remind you that we have a strong team here in the US to support you. Your main reference is Eduardo Bolivar, but there is also specifically our team of 3P for distribution that you can contact us, and we will help you to go through any of your questions, but also any type of quotation that you would like to have from us. So we would like to remind you as well that this is only a presentation of a little portion of the products that are manufactured by Aeroel. We'll be running soon other webinars that are more focused on products for different types of markets and solutions. Like there was also one question more related to machine tool. That will be coming soon. And also we will like doing an additional session related to the same products that we have touched base today. So I would like to thank all of you for attending this webinar. Thank Stefano and Andrea. You did an amazing job to showing us the performance of our products of AeroL. I'm quite sure that we are meeting any request and any needs for future customers. So we wish you all the best. Have a wonderful day. And I would suggest to close the webinar at this point.
Wait a moment that
You can make me, if you like, a host.
Okay.
Okay, thank you all.
You're welcome.